This is a lecture on water and pH for Bio 101 for Monday, September 14th, 2020. And some of the objectives of today's lecture are to talk about what atoms and molecules are, as well as to talk about the chemistry of water and what about this chemistry gives water its abilities to sustain life on Earth. We're also going to talk a little bit about some of the other chemical properties of water. We're going to define some important terms, and we're going to talk about how to use the pH scale to determine whether something is acidic, basic, or neutral. So water is essential for life. About 70% of the Earth is covered in water, and consequently, about 70% of the human body is also made up of water. And so you could see some of those recommended daily water intakes here. For men, this is about 4 liters of water a day, and for women, about 3 liters. So I would like you to take a second and pause the video and just think about what water can do for you. Why do you need to have your body made up of 60 to 70% water? So some of the things you might have come up with can be listed here. A lot of people in class came up with the hydration. It can cure hangovers. It can help to lubricate your joints. And water can do a lot of other things as well. Water can help maintain homeostasis by regulating body temperature, as well as by regulating waste products through the kidneys. It can protect your body organs and tissues, either by moistening them, in the case of your mouth and eyes, or by cushioning them, in the case of your internal organs. And it can also be a transport medium, as blood, to carry nutrients as well as oxygen, because it's a good solvent or a good dissolver of nutrients, and it can allow them to pass through and be transported through your whole body. So we need water in the human body for a lot of different things. And to take a step back, as we talk about water, when we talk about all things, it is made of matter. And matter is just anything that has mass and takes up space. And you've probably seen the periodic table of elements before in your high school chemistry classes. The smallest unit of matter, or the smallest unit that can take up space and has mass, is also known as an atom or an element. And some of the elements are listed here in the periodic table. Particularly important for water are hydrogen and oxygen. Right. And so you can actually take 2 or more elements or atoms and put them together to make a larger, what's known as a molecule. And so 2 or more elements that are bonded together and held together by chemical bonds are what's known as a molecule. And you can see 2 of them listed here, NaCl or sodium chloride or salt, as well as H2 or hydrogen gas. There's 2 elements, sodium and chloride, that are bonded together. And there are also certain types of molecules that are known as compounds, which contain 2 different elements bonded together. So in this case, carbon dioxide. You have a carbon and oxygen elements bonded together, 2 different things. So if you take a moment and look at this water structure over here, we have 2 hydrogen atoms bonded together, that are what these sticks are, to an oxygen atom here. The hydrogens are slightly positive, the oxygen is slightly negative. When you look at this water structure here and these definitions, would you define water as a molecule or as a compound? Take a second, pause the video, and think about your answer. So this is actually a trick question, right? So water is both a molecule and a compound. Technically, it's 2 or more elements bonded together, right? So we've got 3 atoms all held together by these bonds. But the atoms are also different. You have a hydrogen atoms as well as the oxygen. So technically, water is both a molecule and a compound. So all compounds are molecules, but it's important to remember that not all molecules are going to be compounds, because there are some molecules like H2, which is just 2 of the same atom bonded together. And I keep talking about these bonds that are holding the molecules of water together. And bonds are important because they contain energy. And there is a specific type of bond that occurs between the hydrogen atoms in a water molecule and the oxygen atoms of another water molecule. And these are what are known as hydrogen bonds. So a bond between a hydrogen atom that's positive and any negative atom would be considered a hydrogen bond. You can see those highlighted here. And so not only are there covalent or permanent bonds holding the two atoms of hydrogen to their corresponding oxygen to make up one water molecule, there are also hydrogen bonds holding all of these water molecules together to make the liquid water. And all of these bonds contain various amounts of energy. And since these bonds are relatively strong, it takes energy input to break them, it also takes energy to make them. And the hydrogen bonds are specifically important for water, because these hydrogen bonds are one of the things that chemically gives water some of its magical or life-sustaining properties.